Welcome to this new video in which we'll try to find the domain of each function defined by each expression here. We're going to start with the first one. F of x equals 3x squared plus 2x plus 4. This function is a polynomial function. Okay, and you already know that a polynomial function is defined on the set of all real numbers because there is no restriction here. You can put anything or any real number in x. Okay, so the domain of this function f is the set of all real numbers. For the second one, g of x equals 9x minus 9 over 2x plus 7. This is what we call a rational function. It means it's a polynomial over another polynomial. So if you have a rational function, you have to make sure that what's in the denominator here is not equal to 0. Okay, so we're going to solve this. 2x plus 7 equals 0. And here, by moving the 7 to the right-hand side, we're going to obtain 2x equals negative 7. We divide by 2 on both sides, we obtain x equals negative 7 over 2. So the only solution which gives a denominator equal to 0 is x equals negative 7 over 2. So you have to exclude this solution from the set of all real numbers because you are not allowed to have 0 in the denominator. Okay, so the domain of this function g is equal to the set of all real numbers except the value negative 7 over 2. We are done with this function. We're going to move to the next one. H of x equals square root of 2x minus 1. And here you have to know that if you have a square root, you have to check that what's inside is not negative. Okay, you may have 0. So you have to check that what's inside the square root is non-negative. Let's do this. 2x minus 1 greater or equal to 0, which means that 2x greater or equal to 1 by moving the negative 1 to the other side. Now we divide by 2 and we don't change the inequality symbol because the 2 is positive, so we keep the same symbol and we'll obtain x greater or equal than half. Okay, and the real numbers which are greater or equal to half are in the interval. So the domain of h is the interval, the closed interval, half and open at infinity. So the interval is half infinity and this is the domain of h. Now let's move to number 4. In number 4, again, we have a rational function. So it's rational. And when you have a rational function, you have to check that what's in the denominator is not equal to 0. So our denominator here is x squared minus x minus 2, which must be not equal to 0. So let's solve it equal to 0 and exclude the solutions. So x squared minus x minus 2 equals 0. The two solutions, you can use, of course, any method which can solve a quadratic function like this, but my recommendation is to use a simple calculator and you will get x equals negative 1 or 2. So these two solutions have to be excluded from the set of all real numbers for the function k. So the domain of the function k here is the set of all real numbers except those two values which are negative 1 and 2. Now let's move to the last one. L of x equals 2 over x squared plus 1. Again, here we have a rational function and we have to make sure that what's in the denominator here is not equal to 0. So let's solve it equal to 0. So x squared plus 1 equals 0, which means that x squared equals negative 1. And this is never true. A square is never equal to a negative value. So this is never true. So you have no solution for your equation x squared plus 1 equals 0. And since we have no solution, we have nothing to exclude. So what is the set of inputs here? It's gonna be the domain of L equals the set of all real numbers, because there is nothing to exclude. There is no solution for x squared plus 1 equals 0. No real number x makes this denominator equal to 0. Thank you for your attention and see you in the next videos.